So we appreciate you coming out tonight to be a part of this 3D Printing 101. You're going to hear from a couple of individuals tonight. Josh is going to kick it off. Dan's going to step in. We are a makerspace. How many have been here before? Okay, a few. That means a lot of newcomers, so thank you for coming out. After we're done with this, feel free to pull somebody aside like myself or any of the other staff members, and we'd love to show you around. We're a 23,000 square foot space that is all about making. It's tinkering with your hands, and it's a way to get engaged in perhaps things that you haven't done before, and maybe drilling deeper into things that you have and you really want to take it to the next level. So it's a fun spot, it's a community spot, it's a spot where there's a lot of interchange of ideas and always some encouragement from staff and classes as well. And on that note, so tonight we're going to have some coupons for you. If you want to take a class here on Fusion or on 3D Printing 101 as well, we're going to have some 50% off coupons. So another way to come back and participate even further at the Village Workshop. So real quickly too, one of the other audiences here tonight is through Lawrence Tech. And Mark is the executive director of the Collaboratory at Lawrence Tech. We've done some things, we've collaborated before. And we've had Mark out with his team, Detroit area makers and manufacturers, and tonight you're representing yet another endeavor. Sure. Give us a quick shot on that one.
Sure. Thanks for having me, and thanks. This is a great presentation and great venue. Again, my name is Mark Brookie. I'm Executive Director for the LT Collaboratory. We're a business accelerator that helps hardware startups and second stage businesses grow their business. We'll be opening up about a 17,000 square foot facility here over the next year that will help companies grow even more. We had a meetup group called Detroit Area Makers and Manufacturers that was recently converted to Detroit Hardware Massive. Hardware Massive is a global organization that we connected with to really bring some global expertise and connections to the hardware startup market so that we can help bring guest speakers from around the world, around the country here, as well as really try to be a little bit more cohesive in what we're doing as far as taking products to market. So we've been here a couple times and held our meetups here. It's a great facility, great programs, and really excited. I mean, it's one of the only places in Metro Detroit that has this kind of facility. So we're really excited to see so many people here, and really very excited about seeing what's here tonight. So thank you.
Thanks, Mark. All right, so without further ado, something's cooking on the printer, and Josh, take it away. Let us know what's going on.
All right, well, good evening, everybody. Welcome to 3D Printing 101. My name is Josh Osborne. This is Julie Osborne. We run a local 3D print service bureau called Telemetry 3D, and today we're here to talk to you guys about 3D printing. So you've probably heard about 3D printing from a family member, a friend, or on the media somewhere, and you've heard pretty much everything. You've heard that 3D printing is going to change the world, it's going to disrupt industry, and we're going to talk a little bit about the realities. What really is 3D printing? Well, 3D printing is just a kind of a buzzword. It's a catch-all term for a bunch of different additive manufacturing processes. So it's additive manufacturing versus subtractive manufacturing. So you can start with a solid block for subtractive manufacturing. You can start with a solid block of wood or of metal or of plastic. You can stick it on a mill, and you can chisel away to subtract away the material to end up with your final prototype. Or with additive manufacturing, you can add material layer by layer by layer to produce your final model. So 3D printing is just a catch-all term for a bunch of different additive manufacturing processes that print layer by layer. So with 3D printing, you are adding one layer right on top of another. So in this demonstration video, you're seeing it. It's a printer very similar to this one. It's highly sped up, and you're seeing it lay down layer by layer by layer on this Yoda bust and to fully build up that model. Now it's been, like I said, it's been sped up probably about 100 times or more. 3D printing is not particularly fast. So why does this matter though? What's the big deal about 3D printing? Well, because creating precise three-dimensional objects with a lot of different design features has traditionally been incredibly difficult and takes a long amount of time. So with 3D printers, you can, with one tool, produce almost any geometry that you can think of. Maybe not any geometry, but almost any geometry that you think of. So before, where you would need dozens of tools and dozens of technicians to produce a functional prototype, you can now do that with one machine, with one skilled operator. And you can print high amounts of detail with these printers. So things that were only you could only do by hand in the past. You can print extreme amounts of detail with the various processes. So again, why is 3D printing important? Well, the most important aspect of it is the compression of the design cycle. So before 3D printing, you would come up with your design, you would send it out to be prototyped, and it would take several weeks to get your models back, only to find out that you missed a design feature that needed to be fixed, and then you fixed it, sent it back, and a few more weeks later you got your prototype again. Well, now with 3D printing, you can come in on Monday morning, you can make your design. If it's small enough, you can get it started Monday night, walk into the office Tuesday morning, and you have your first iteration done. Oh, you made a mistake. You fix it, you get it printing again. Wednesday morning, you've got your second iteration. Maybe by Friday, you've already got enough iterations, you've got a final model that's ready to go for being made into injection molds. So 3D printing compresses the design cycle, and it's accelerating innovation by allowing people and companies to move a lot faster. So 3D printers now can print into a large variety of materials. What you'll probably be mostly interfacing with are 3D printed plastics. All of the examples that we have here today are 3D printed plastics. And there's a wide variety of plastics that are available for 3D printing. And they all have their own strengths and weaknesses and their own specific chemical properties. You can also print directly into metals with a metal sintering printer that uses powders and a high-powered laser to sinter metal powder together. So you can print directly into metal, flexible materials. People are actually learning how to print collagen and the materials in the extracellular matrices to be actually to print the structures of organs, which are then seeded with stem cells and placed in conditioned media to try to actually grow functional organs. And people are even are making 3D printers that can extrude concrete and create concrete forms and actually build houses. That's a little bit kind of off, a little bit larger of a format, but it still kind of falls within the realm of 3D printing. Now, there are a large array of processes that fall under the umbrella term of 3D printing and additive manufacturing. But broadly speaking, there's three processes that they fall within, and that's selective binding, selective solidification, and selective deposition. So let's take a look at those. So with selective binding, you're generally going to be starting with a thin layer of powder. It can be powdered plastics like nylon, it can be metals, it can be titanium, it can be, there's a large amount of different powders that you can work with. And then a laser comes along, a high-powered laser, and it fuses those particles of powder together. And then the machine spreads out another thin layer of powder, and then a high-powered laser comes again and sinters the next layer to the previous layer. And it does that until you build up your final model. So that's selective binding. Selective solidification, a stereotypical process for that is SLA stereolithography. This is actually the first 3D printing process that was patented in 1984. What it does is it uses a UV laser to cure a liquid resin in a vat. So it's selectively curing or selectively solidifying layer by layer by layer. And then there's selective deposition. This is what you're probably most familiar with. This is the sort of technology that this printer uses, fused filament fabrication or fused deposition modeling. It just uses a plastic filament that is then pushed through an extruder and pushed through a hot nozzle that's then laid out layer by layer to build your object. So I said that 3D printing falls under 3 broad categories. Well, there's so much development that's going on in the field that's not exactly true. It's generally true, but it's not exactly true. There's new 3D printing technologies that are being developed all the time, including 3D printers that actually take pieces of paper to create your 3-dimensional object. So it'll take a piece of paper, it'll cut a tool path around it, put a small layer of glue on top of that, put another piece of paper on top of it, and cut out another tool path. And it'll repeat that process until you've produced an entire object made out of paper. So there's going to be unique strengths and weaknesses to each of these technologies. And that's something you're going to want to consider if you're thinking about using 3D printing into your workflow. Because obviously there are printers at every, there's technologies that are available at every price point. So if you don't have a lot of money to spend, you might want to go with a lower resolution prototype until you've worked out your final design. So there's strengths and weaknesses you're going to want to consider between the different methods. And then within each technology, you can often choose the resolution that you want to work with. So lower resolutions will print out a lot faster and tend to be a lower cost, but obviously you start getting some layering artifacts. But so it's something that you want to consider. So again, it's building up layer by layer by layer. The more layers that you have, the finer details that you can resolve, but the longer it takes, and therefore usually the more expensive the parts become. So at Telemetry 3D, we offer high-resolution SLA printing services, high-resolution fused filament fabrication services, and our SLA is great for functional mechanical prototyping, high-precision artistic models. Our fused filament fabrication services are fantastic for very large mechanical models. It's a full prototype of the steering column there. But fused filament fabrication actually is really nice for small models as well. It just can't resolve the tiniest of details. So I'm going to go ahead and hand it over to Dan here. He's going to talk from a design perspective.
Thanks, Josh. Hi, everybody. My name is Dan Ingerer. I'm with Brainchild Engineering. We're a product design and engineering service. We actually have our office upstairs. And we use Telemetry 3D a lot in our prototyping process to make parts, turnaround parts really quick. In fact, we're going to be using this part tomorrow morning. So as much as we really love 3D printing, I wanted to talk about some of the limitations. Because right now you're probably thinking like organs, houses, what can I not print? Can I go make myself a toaster or a Rolex watch? So why can't you do those things? And I wanted to illuminate some of those challenges. So first of all, one of the challenges is multi-material. So in your standard household products like a toaster, you've got maybe 5 or 10 different materials. You've got the thin sheet metal on the outside, plastics, the copper wiring, maybe a circuit board, all kinds of stuff. And currently, as it stands, you can't quite make all those materials in one print. You have specialized machines that can do plastic extrusion, selective layer sintering for metal, but currently there's no machine that can do it all just yet. Now, that's constantly evolving and changing. There are printers out there that can do plastic and rubber-like at the same time. So, of course, ask me again in 5 years, and maybe you can make a toaster. But currently, it's not quite the Star Trek replicator kind of thing. Next, material properties. So strength, for example, say you have a gear set, and gears are oftentimes heat treated because just normal plain mild steel is not quite strong enough. So you'll send the parts through a furnace and change the outer surface into an extremely hard material. You don't get that with 3D printing. You're not printing individual molecules, and that's something that's in the works, but again, not quite there yet with the technology. Another thing is surface finish. So for, say, a ball bearing or a gear set, for gears to mesh, you need extremely smooth surface finish, which is achieved through dedicated processes like lapping and grinding and things like that. 3D printing, while you can get incredible detail in plastics, with metal, it's just not there yet. And the resolution in general, depending on the process and the material, it's just not perfect at the moment. You can't print absolutely anything, unfortunately. Finally, assembly. So for example, say you have an object that has springs inside it. You can't just print a complete assembly in one sitting. For example, when you're assembling springs, you need to start out in the free state and compress it down so that the spring actually has internal stresses to give you the spring force. So if you were to print a spring in its compressed state, it wouldn't actually spring back. It would be stuck, if that makes sense. So finally, 3D printing, as you can see, is somewhat slow compared with mass production processes like injection molding, casting, forging, all kinds of dedicated processes. They're much faster. Once you make the mold or the tooling, you can crank out parts maybe 1 a second or more. So 3D printing, that's the trade-off. There's an extremely low barrier to entry. You just get a 3D printer for a few hundred or $1,000 and you're making parts. But it takes hours. Whereas with, say, injection molding, you spend $10,000 on a mold for one little part, but when you need to make 100,000 a year, you can't sit around and wait 5 hours for one part. So while we really love 3D printing and we use it literally like every day of the week, we're farming out parts asking us, hey, we have this small plastic part, we need to make one tomorrow. It's great for that. It's not the be-all end-all, but again, 10 years ago, 3D printing was nowhere near where it is today. You can get a printer like this for less than $1,000 and make parts in your bedroom. So, again, 5, 10, 15 years from now, who knows where we're going to be. But I just wanted to bring a little reality to the things. Thank you.
Thank you, Dan. So yeah, there's quite a few limitations with the processes. And part of the limitations is that, thank you. Part of the limitations is when you're printing these layer by layer. So I don't know how many of you got a chance to really look at what's going on with this printer here. But because you're printing layer by layer, sometimes you're going, depending on your model, you're going to reach a certain height and you're going to have a little design element, say like a little ledge up here. So what is the printer going to do when it gets to this point and there's nothing printed underneath of it? Well, it can't just print in mid-air. It's going to fail. So you have to actually print support materials underneath of it, and those support materials have to be cleaned off and they can leave scarring. And so that's something that you're going to want to consider if you're doing a lot of designing for 3D prints and sending prints out to shops, is that if you've got really intricate structures, which we hope that you do, it's going to require a lot of support material to be generated. And you have to pay for that material and it costs a lot of time. So if you can think in terms of layers, you might be able to incorporate that into your design in such a way that the parts don't even require support material, which produces prettier parts quicker and much less expensive. But it's okay if there's some scarring on it, because most 3D prints are really amenable to being post-processed. So if your parts, if you need to sand them up, you can sand them, you can prime them, you can paint them, you can clear coat them. You can do pretty much everything you want with 3D printed parts. So yeah, this part right here, it was actually a really low resolution model that we printed out that was then sanded up, primed, painted, and then clear coated. And I mean, you can't really tell that it's a really, really low resolution model. And you can kind of see here. So we did a Lincoln mask right off of the printer. You can see some layering artifacts here, but after some sanding, priming, and painting, and clear coating, and maybe that wasn't the best color choice, but but after the sanding, priming, and painting, it became a really nice, smooth model that can be easily handled. So that's about it. I hope that this was informative, and I hope that you guys are walking away with some information that